We're going to talk about combinations now. Combinations are fun. Combinations. Suppose there are 3 drinks. 3 drinks. Drink 1, drink 2, and drink 3. And you want to choose 2. And the order doesn't matter. The order doesn't matter. Well, you can choose drink 1 and then drink 2, or drink 1 and drink 3. So I did drink 1 and with 2. I did drink 2 with 3. I said order doesn't matter. So when it comes to drink 2, I'm not going to say drink 1, because that's right here. Drink 2 and drink 1. Always go say to the right. I'll do drink 2 with drink 3. And I did drink 3 with everything. I did drink 3 with 1. I did drink 3 with 2. You can pick drink 3 and drink 3, or drink 2 and drink 2. How many different combinations did I make? The answer is 3. From these 3 drinks, I chose 2. And there are 3 different ways. Okay, what if let's actually write it. From 4 shirts, pick 2. 2 shirts. You go shopping and you find 4 shirts that you really, really like. But you can only afford to buy 2. And of course, the shirts will be shirt 1, shirt 2, shirt 3, shirt 4. What are the different combinations that can come up if from 4 shirts you pick 2? Well, you can pick shirt 1 with shirt 2, or shirt 1 and you can buy shirt 3 with that, or you can buy shirt 1 and shirt 4. Or you can buy, so I did 1 with each of the others, S1 with each of the others. Now I do S2. I can buy S2 and S3, and S2 and S4. And then I can buy shirt 3 and shirt 4. There are 6 different combinations. These are combinations. Now, if the question said, how many different ways can you pick 2 shirts from 4? You want to be able to come up with the number 6 without listing them. I mean, after all, what if this list had 2,000? Do you really want to list 2,000? And if you did attempt to list 2,000, do you think maybe you might miss 1 or 2? And in my case, the answer is obviously yes. I would certainly miss some. Okay, so that means we need a formula. The formula is as follows. We'll write it down as a question. How many different ways can you choose we'll call them objects, from n? N objects. How many different ways can you choose R objects from n? And the notation I'm going to use this notation. This means N choose R. Some books, possibly yours, actually, there's a couple of other notations. Let's see if I remember some. Some will write C for combination, NR. Others will write NCR. I am going to write NR. And they all are read as N choose R. You want to choose N choose R. You want to choose R objects from N objects. Okay, so now the formula is, it's the first number, we'll call that first and that second, it's the first number factorial divided by the second number factorial divided by the difference of the numbers factorial, n minus r, n minus r, n minus r, factorial. A little while ago, we chose two objects from 4. The top number goes on top, the bottom number goes on the bottom. The difference, 4 minus 2, which is 2, goes on the bottom factorial. 4 factorial is this, and 2 factorial is just 2. So we have 2 factorial twice. 2 goes into 4 2 times. 2 goes into that 2 one time. 2 times 3 is 6, times 1 is 6. I think we also did from 3 choose 2. The top number goes factorial on the top. The bottom number goes factorial on the bottom. And the difference, 3 minus 2, or 1, goes factorial on the bottom. Don't bother with 1 factorial. Don't bother with dividing by 1. This is 3 factorial. This is 2 factorial. The 2's cancel. You get 3. For the record, by definition, 0 factorial is the number 1. That's the only n factorial that doesn't follow the standard rule. 0 factorial is 1. So for example, if somebody asked you, how many different ways can you choose 5 objects from 5 objects? How many different ways can you choose 5 objects from 5? In how many ways can you choose 5 objects from 5 objects? The answer is 1 from 5 objects. The answer is 1. If there are 5 objects on the table, if there are 5 objects on the table and you were going to choose 1, say the numbered 1, 2, 3, 4, 5. There's 5 different ways that you can choose one object. You can go up to the table and choose object number 1, or number 2, or object number 3, or you can go up and pick object number 4, or you can go up and pick object number 5. There are 5 different ways to pick one object. But how many different ways are there to pick all 5? And the answer is 1 way. You have to pick all of them. And this works. From 5 objects, you want to choose 5. So the top number goes factorial on the top, the bottom number factorial on the bottom, and then the difference, 5 minus 5 is 0 factorial on the bottom. 5 factorial over 5 factorial, well, 0 factorial is 1. Don't bother with 1. Now, 5 factorial is some number. I don't care if it's 120 or 2,311. I'm dividing by the same exact number. And if I divide by the same exact number, I hope it's very clear what we're going to get. We're going to get 1. And to convince you that I'm right about choosing one object from 5, well, the 5 factorial goes on top, the 1 factorial goes on the bottom, 5 minus 1 is 4 goes on the bottom, 1 factorial is 1. The rule for dividing by 1 is don't bother. It won't change anything. 5 factorial is 5 times 4 times 3 times 2 times 1. But I know a short way of writing 4 times 3 times 2 times 1. It's called 4 factorial. Oh, look at that. I'm dividing by 4 factorial. The answer is just 5. There's 5 different ways of choosing one object from 5. Now, there's a very interesting thing that happens here. Every time you choose one object from 5, you're also choosing 4 objects. If there are 5 objects, A, B, C, D, and E, and you are asked to pick one, say you go to pick that one. Well, there was another way to do that. You cannot pick those 4. You can pick those 4 not to pick. That is, if 5 people come to your business for a job interview, and you only need one person, there are 2 ways of doing it. You can pick the person that you like the most, A, or you can say, let's see who I really don't like. I really don't like E. And now that E's gone, the person I like the least is C for this job. And now that those 2 are gone, D's out of here. And of the remaining, I don't like B. Oh, so I'm picking A. Okay, every time you pick 1, you're also picking 4. For example, and this is probably a better example. It's exactly the same. If somebody asked me to pick 4 people to hire, if somebody said, there are 5 people out of my office, I want you to go there and hire 4 of them. If you think I'm going to bother to handpick 4 of them, you're mistaken. I'm going to say, C, go home. And as a consequence of that, I picked 4. Okay, picking 4 from 5 is the same as picking 1 from 5. Let's look at this, and then we'll prove it. Picking 4 from 5. We'll prove it in general. 5, choose 4. Well, first you write 5 factorial on the top, and then you write the 4 factorial on the bottom, and then you do 5 minus 4, which is 1 factorial. Well, 4 factorial is a number, 1 factorial is a number, they permute. You can say, oh, it's 1 factorial times 4 factorial. But isn't that 5 choose 1? Isn't that just the same as 5 choose 1? 5 factorials on top, 1 factorials on the bottom, 5 minus 1 is 4, that's on the bottom. Okay, oops. Maybe I should not hold the marker, else it'll erase. Hold the eraser. Okay, let's say that again. 5 choose 1. Well, 5 factorials on top, 1 factorial is on the bottom, 5 minus 1 is 4, there it is. They're the same. Notice that 4 plus 1 add up to 5. we can do this in general. N choose R is equal to N choose, well, not the R, but the remaining. If you have R objects, if you have N objects, and you remove R, you'll have N minus R. Notice they add up to N. If you have N and you take away R, but then you add the R right back, you get N. These two are equal. These two are equal. And that's a theorem, and you prove theorems. Doesn't want to erase, does it? There we go. Okay, you prove theorems. THM for theorem. Well, N choose R, and here's the proof. N choose R, by definition, it's the top number factorial. It's the bottom number factorial times the difference, top minus bottom factorial. Now, you don't even have to do this next step, but you can. Let's switch the order of multiplication. This is N minus R factorial times R factorial. Now, I claim that this is N choose R. Well, well, of course, that's true. Okay. So I claim that this is N choose N minus R. And of course it is. The top number is there, factorial. The bottom number is here, factorial. And if you do the top and you take away the bottom, this is N. This is a 1 here. Minus N is 0. Minus a negative R is plus R. We get R, which is right there. They're equal. Okay, from 10, choosing 2 is the same as choosing 8. If there's 10 people in a room and somebody says, choose 8 of them to be on the basketball team, or, it's easier to choose 2 and say, you 2 people, go home. Go home. We don't want you. We have better players. Suppose there's a committee. There are 5 men and 3 women. They're running for office. And you want to choose, they want to be on a committee, say. Choose a committee from the 5 men and 3 women consisting of 2 men and 2 women. In how many ways? In how many ways can you choose a committee consisting of 2 men and 2 women from 5 men and 3 women? Okay, so how would you do this? You need to choose or pick, you need to choose 2 men from 5 men, and then. This is a key phrase. That means multiply. And then choose 2 women from 3 women. Okay. So we're going to multiply. You want to choose 2 men from 5. Well, that's 5. Choose 2. And then you want to choose 2 women from 3. I want to choose 2 from 3. 5 choose 2. Well, it's the top number factorial, the bottom number factorial, and then the difference, 5 minus 2 factorial, times. Now, the next one, I can write it out the same way that I just did this, but it's an obvious answer. If you choose 2 from 3, if there are 3 objects, and you choose 2 of them, you left 1 behind. You could have left that one behind and picked the other 2. That's one way. Or you could have left this one behind and picked the other 2. That's the second way. Or you could have picked that one and left the other 2. You could have left this one behind and picked the other 2. There are 3 different ways of picking 2 objects from 3. There are 3 different ways. You want to write it out? This is 3 factorial. That's 2 factorial. 3 minus 2 is 1. Factorial is 1. I won't bother doing that. But this is 3. After all, 3 factorial is 3 times 2, and 2 factorial is 2. It's 3. Okay, but if you like, you could cancel this out. So the 5 factorial survives. 5, 4, 3, 2. And there 2 factorial survive. They're each 2. 2 times 2 goes right into 4. You're left with 5 times 3 is 15. Times 2 more is 30. So there are 30 different ways of picking this committee. And earlier when I said at the very beginning of the video, I think everyone should know how to count. This is what I mean. You should know how many different ways you can pick the committees. Let's talk a little bit about the lottery. I think that there are, 30 numbers? I'm probably wrong. There are 30 numbers, and you want to pick 5. There are 30 numbers, you want to pick 5 of them. The order doesn't matter. So, I didn't mean to write 30 factorial. It's 30 factorial divided by 5 factorial. It's going to be a very big number. I used to know this number. All I can say at this point is it's in the millions. I think it's around 8 million, if I remember right. Shucks, I don't even know how many numbers there are in a lottery. But if there are 30 numbers and you want to pick 5 of them, the order doesn't matter. Like if you pick 1, 2, 3, 4, 5, and when these are the numbers on your lottery card, 1 and then 2. When the drawing comes, if 2 comes up first, and then 3, and then 5, and then 4, and then 1, you just won the lottery. The order didn't matter, and that's very important. We're going to come back and do some more problems involving combinations and permutations in the next video.